Hey, Janie. My voice is a little shaky today, but you're the only one that's shown up. So you get to have me to yourself and you can tell me whatever it is that you would like help on.
I was having trouble with like the composition problems.
Okay, so on practice A,
Yeah.
starting with 19 or further down or 13?
Like 20. Yes, 20 through 24.
20 through 24?
Yes, ma'am.
Okay. All right. Oh, I'll be glad to help with that. Those can be a little tricky. Let me share my practice A with you, my screen with you. Hold on. Sorry. All right. So perform the indicated operation. So what you're going to do is figure out what h of x is first. But obviously, it's already defined at h of x. So what we're going to do then is plug in this into here. Okay? So that's going to look like 2 times x minus 4 all over 2 plus 5. Okay?
Okay.
Did I plug everything in right?
I think
These are one of those that you just kind of want to go back and double check your work and make sure that you plug everything in.
I was confused like when it has plus 5, if you put that with the 4 or if you put that with the 2.
Oh, I got you. Well, you would actually kind of work everything out within like you're gonna 2x because you really what you're doing is plugging. I'm sorry, I'm not explaining myself well. Apologize. You're really plugging this whole piece in for the x. So then you kind of want to work it. So you're going to distribute this 2 into that. So that's going to make that minus 8 all over 2 plus 5. And now what you want to do is get this 5 to have kind of a common denominator. So whatever you can combine. So that's going to be 10 over 2. And then that makes it where you can combine everything. So now you've got a negative 8 really and a plus 10. Does that make sense? So then that's going to be 2x plus 2 all over 2, which then that cancels everything out and you get x plus 1.
Okay, I think I understand that.
Okay, let's kind of go back. All right, let's just go back and kind of talk about it. Well, it is really confusing. I can see, where it is. So let's just kind of go back and recap what I just did because I don't think I explained myself well the first time. But basically what you're doing when you're solving when it's already of x is whatever that whole function is, that h of x piece, you're actually literally setting that whole function in for just that variable in the g of x. And then that's when your principles of parentheses, exponents, addition, subtraction, all of that kind of comes into play. So this first step is just that substitution step. And then the second step is me distributing the 2 to everything inside the parentheses. So that basically this is a 2 over 1. So I'm substituting the 2 to the x and the 2 to the -4 and then multiplying straight across. So that gives me this result here for this first part. And then I'm just bringing this 5 down and then realizing that I have to have a common denominator before I can combine all of that. This actually is a number and this is actually a number. Really, almost. Oh, that made a heart. But you've got 2x over 2, and then you've got a -8 over 2. Does that make sense?
Yes.
Or not really? Okay. And then, so then you're actually combining the -8 over 2 plus the 10 over 2 because they're like terms. And that gives you a 2 over 2. But basically that breaks down. I just put the whole thing over 2, but whatever way makes it easier for you to think about. And then I see that I can take a 2 out of everything. If I couldn't have done that last step. But then I get x plus 1.
I think that makes sense.
You think it does?
Yes, ma'am.
Where, if I lost you, where did I lose you, would you say? Just maybe needing a little more practice just to make it proficient?
Before, I was just adding the 5 to the -8.
Okay, I got you. Oh, okay. I see what you're saying. Yeah.
I didn't get the common denominator, so.
Oh, okay. All right. And now we've got h of x, which we're working with this one again. And then we're going to plug it into the f of x. So that's going to be 2 times, and then it's x minus 4 all over 2 raised to the -1 power. And this one, because it's a fraction raised to the -1, it actually inverses before you distribute. Because, let's talk about that for just a minute. Remember with the please excuse my dear Aunt Sally?
Mm-hmm.
You have to deal with the parenthesis or the exponent first before multiplication, because this is really, even though that's within parentheses, it's really being multiplied. Does that make sense to you?
Yes, ma'am.
Okay. All right. So this actually then becomes this because of the -1. All it's doing is inversing. And then you distribute your 2.
Would you not distribute the 2 to the bottom part?
No, because technically, good question. Technically, let me erase this. Technically, this is 2 over 1. And when you multiply fractions, you're multiplying straight across.
Okay, I think that makes sense.
All right, so this just basically inverses the fraction within the parentheses. And because it's an exponent, it comes before the multiplication. And the only reason the parentheses are there is because it's showing that it's being multiplied.
And for 25 through 30, what do you mean, or what does it mean by like state the domain?
Good question. Remember briefly yesterday I talked about, I'm sorry, what'd you say?
I remember doing it from like chapter 1 or 2.
Yes, ma'am. And basically what it means is when you have something like this, you can't, the 2 could not be in the operation because it would make the denominator 0. So like when you're looking at it, if you look at f of x equals 2x plus 2, there's not anything that's really going to limit that because it could be all real numbers. So if I'm adding those together, 2x plus 2, and then g of x, which is x squared. So that kind of trims back to this when you just kind of put it in descending order, right?
Mm-hmm. So then the answer would be all real numbers?
Uh-huh.
Oh, okay.
Oops, I'm not going to write it all out. But if you look at, I'm trying to find one that has the h of x in it. Okay. Number 26. If I have 3 over x minus 2 minus 2x plus 2, that's technically over 1. But this right here is going to limit the domain. So that's going to be all real numbers except 2.
Just 2?
Yeah, except where x equals 2, if you want to write it that way. Does that make sense? And that's really all you have to do for those is state the domain. You don't really have to work them out. So any of them, really, to be perfectly honest with you, actually, that's true. Some of them you will have to work out because actually when you do the combining, it's going to actually change what it would be. But like for number 26, it's all real numbers except for 2. 27, multiplying, going straight across, it's going to be all real numbers except for 2. And let's see what happens if we do this. If we do g x squared divided by f of x, 2x plus 2. That can, what would x have to be in order for a 0 to be in the denominator?
-1.
So it's all real numbers except for negative x equals -1 for 28. Does that make sense?
Yes, ma'am.
That's for 28.
For 28, what would be the answer? Because I was trying to solve that one.
Oh, it's this is the, I mean, you could write this if you wanted to, or you could write this. But it doesn't reduce down any more than that.
Okay.
Does that make sense?
I think that was confusing.
I'm sorry?
I thought we had to solve this.
No, it says let this, as for all of these. You kind of have to solve them, but I mean, it's not going to go beyond that. Like this one doesn't. I can't think of any others that go beyond that. But what you're trying to do is figure out, because the main instruction is to state the domain of the operation. Mm-hmm. So you have to get it to the point where you can figure out what's going to be in the denominator, because really that's going to be the limiting factor in this, because we don't have anything that has a square root in it, right. And there might be a limiting factor within that, because then you would go into imaginary numbers. But in this case, the only thing we have is something that you don't want 0 in the denominator. That's the case of all rational expressions that have variables in the denominators, that you can't have a 0 in the denominator. So that's why it's asking the question about the domain.
Oh, okay.
You just can't have a 0 in the denominator. No 0 in the denominator. So you want to solve these, like any of them that involve this, you probably should take a look at, but then when you get down into these division ones, obviously, it's going to change.
Mm-hmm.
Okay, so what 29? Maybe there is g of, oh, this is a combo. So if I take x squared, okay, there is going to be a square root one. So this one, you're sticking, oops. Did I do that right? No, I didn't. G, so it's, sorry, 3
okay.
over x squared minus 2. Okay, so that's this one. You had to solve it to here. Does that make sense?
Yes, ma'am.
So you see where I got that? And now you have to figure out what would make that a 0. Take the square root of both sides. X equals plus or minus the square root of 2. So it would be all, number 29 would be all real numbers except, oh, I don't know why I keep writing it out. All real numbers except plus or minus root 2 for number 29.
Okay.
Do you see that or not really?
I understand.
Okay. It's just where the denominator is going to be 0. So you have to, I was trying to take a look at them because I hadn't really gotten to those yet. I've only worked through like number 19 by hand. I was trying to get it all done before math lab, but so I haven't really worked. And I was trying to just take a look at them and try to guess at the answers to see which ones. And so that's why I was not thinking any of them that have H in them. Most definitely, you've got to think about the fact that there could possibly be something that's going to be limited because there's a variable in the denominator. And so you already know the domain is going to be limited. And then this one, because it was a division problem, number 28, because it was a division problem, it's going to be limited. But the answer to number 30 is all real numbers. So 26, 27, 28, and 29 have exceptions to them because they're either division problems or they have that h of x function in it.
So if they're division, they'll always have an exception?
Not always, but generally, yes.
Okay.
Like the way, yeah. Yeah, when stating the domain, I would venture to say yes, just because with a variable in the denominator, there's a possibility that you want to stress that it can't be something that would make the denominator 0. That's the main thing.
Okay. I think those were the only questions I had for you.
Okay. Well, great. How did you do on the worksheet yesterday? No problems with it?
The 3.1 to 3.31.
Yes, ma'am.
I think that one was pretty easy
Okay, good.
because it was just review.
Yes.
Thank you for helping.
Oh, hey, no problem. Thanks for coming to Math Lab.
Have a good day.
You do the same. Hey, Jake. How are you?
I'm good. How about you?
I'm doing good.
Awesome. All right. I'm gonna grab my plate real quick for breakfast day.
Okay. She did she give you practice A
Yes,
also?
we did.
Okay.
Actually, hold on, I gotta print it off because I lost my copy. Hang on.
Okay.
Okay. Let's see. Okay, I'll be right back.
Not a problem.
Okay, I'm back. So
Okay.
she wanted us to do problems 1 through 12, 25 to 28.
1 through 12. Okay. All right.
So let's see.
All right. I'm sorry.
So
I was just finishing up a problem.
Okay.
All right. So you want to start at number 1 to kind of get you going?
Yes, ma'am. Sounds good.
Okay. All right. So what you're doing here is just taking this function, f of x, okay, and you're adding to it this function. So what I typically do to try and keep it kind of neat as I possibly can, is put them in parentheses and then combine like terms.
Okay.
Whoops. So I'm going to write it over here to the side. I've got x to the 1/2 plus 2, put it in parentheses, plus 3x to the 1/2 minus 1. So I notice that my x's have the same exponent, so I can just add those. So x to the 1/2 plus 3x to the 1/2 gives me a 4x to the 1/2. And then 2 plus a -1 gives me a 1. And that's my final answer.
Okay. Finish writing that out. Oh, so you just combine like terms.
Yes, sir.
Okay.
That's all.
All right.
Not too bad.
Mm-hmm. Okay. I'll try number 2 by myself, and then we'll compare.
Okay. Yep. And then you just let me know what you got.
Sounds good.
Yeah, number 2 and number 3 are pretty straightforward. And then you start with the minus, and you just have to make sure you distribute. Go ahead and use your parentheses and make sure you distribute.
Okay. All right, I have my answer.
Okay. What'd you get?
-x to the 1/2 power plus 5.
Perfect.
Awesome.
Nailed it.
Okay.
Did you want to try 3 by yourself?
Yes, ma'am, I can.
And then we'll do number 4 together.
All right. All right, I got x to the 1/2 power plus 2.
I'm sorry. Let me. That was number 3? Yes, sir. Knocking it out of the park. Good job. All right, let's work on number 4 together just to make sure I get you started off on the right path, hopefully. Try real hard not to lead you guys astray, plus 2, and then minus 3x to the 1/2 minus 1. So basically what I want to do is distribute that negative throughout the parenthesis. Okay?
Both of them?
Make sure I do that. So now I have x to the 1/2 minus 3x to the 1/2. So that's going to be negative 2x to the 1/2. And then I've got a plus 2 with a plus 1. So that's going to be plus 3.
Okay. Pretty straightforward.
Yeah.
Flip the signs for the parentheses.
And that's why I try to make sure on things, particularly when it's just adding and subtracting, that you use the parentheses, because it keeps everything, so that when you do move that negative throughout, that you distribute that, it comes out. And you don't skip any steps.
Okay. All right. So I'll just do number 5 by myself.
Okay. And I'm going to erase this to kind of get us ready for when we start on 7.
Okay. All right, I got negative 3x to the 1/2 power plus 1.
That's number 5. Is that the one I'm looking at?
Yes,
That's it. Perfect.
All right, I'll do 6 real quick.
Okay. You're doing great.
Awesome, thank you. All right, I got 5x to the 1/2 minus 4.
That's perfect.
All right.
You're doing great.
Yes, thank you.
All right. So now on 7, we're going to be multiplying the functions together. So we've got 4x to the 3/2 times 2x to the 1/3. So we can multiply our constants just like normal, and that's fine. But with our exponents, we have to add with our variables, we have to add the exponents.
Okay.
So those will have to have a common denominator. So I'm going to make that 6. 2 goes into 6 3 times, and 3 times 3 is 9. So x to the 3/2 becomes x to the 9/6. And 3 goes into 6 2 times, and 2 times 1 is 2. So x to the 1/3 becomes x to the 2/6. Now I add my numerators, 9 and 2. So my final answer is 8x to the 11th over 6.
Okay.
And that's my final answer.
Okay. I'll try to do 8 on my own.
Okay. One of them, and I can't remember which one. Actually, it is number 8. You come out even though yeah, the Lord help me, the denominators are the same and your exponent actually comes out even. So it's kind of a nice one.
Okay. So I got negative 24x and to the 4 halves power, so 4 over 2. But I can reduce.
Which that reduces to, right.
So
And that's it.
times 2.
It's negative 24x squared.
Oh, yeah.
Because that 4 over 2 reduces to 2. Does that make sense?
Yes, ma'am.
So your final answer should, because it was this at first, you can reduce it to this.
Got it.
Okay?
Mm-hmm.
And that was number 8.
Okay.
Okay, so are you going to try number 9?
Yes, ma'am.
Okay. And then we'll do number 10 together since it's the first division one.
Okay. All right, I got minus 12x raised to 5 over 6.
That's perfect.
Awesome. I'll move on to, yeah, we got to 10.
Okay, we'll move on to number 10. And we've got f of x over g of x, which looks like 4x to the 3 halves over 2x to the 1/3.
Okay.
Which I can actually reduce my constants where we'll have a 2 at the top only.
Okay.
And then I want to change my exponents to have a common denominator. And that will be 6. 2 goes into 6 3 times, and 3 times 3 is 9. So my x to the 3 halves becomes 9/6. 3 goes into 6 2 times, and 2 times 1 is 2. So my x to the 1/3 becomes x to the 2/6. My exponent rules tell me I need to subtract my numerator 9/6 from my denominator 2/6. So that's going to leave me 2 x to the 7/6.
All right. All righty. I'll solve for 11.
Okay. Good job.
It's negative 6 divided by 4. I have like 0.5 or something like that.
Yeah, but what you need to do is just actually, instead of putting a 0.5 because you're already working in a fraction, just divide 2 into both of them. And I think you'll end up like with the 3 on top and the 2 on the bottom.
Okay.
So that would be better for this particular problem anyway.
Okay. And you add the numerators or you subtract them?
On 11, you subtract them.
Okay, so 1 minus 3. That gives us negative 2 over 2, so just negative 1?
What? Yeah, well, yeah. So that means that x would stay in the denominator. Does that make sense?
I think, can I explain?
Do you want to see it?
Yes, ma'am.
Okay. So negative 6 x to the 1/2 over 4 x to the 3/2. So that gives me negative 3 over 2 with 1 minus the 3/2, which basically is you end with a negative, which tells me it's going to be down here at the bottom. So it really just, oops, it doesn't go there, does it? When you're combining, it just stays in the denominator. When you're combining top and bottom, whatever the result is. So like if it turned out to be positive, it would be at the top. But if it turns out to be negative, it stays in the bottom.
Okay. Oh, okay. All right.
Okay. So because it turns out to be a negative 2 over 2, it just stays in the bottom when you're combining top and bottom. If you weren't combining and you end it, so this is actually what your final answer looks like.
Okay.
If you weren't combining, then and there was a negative on the bottom, it goes to the top. But when you're combining and it's top and bottom, you just leave the variable wherever it would be designated. If the result is positive, it stays at the top. If the result is negative, it stays in the bottom.
Okay. All right. All right, so I'll go ahead and I'll work on 12.
Okay.
Give that one a shot.
Yeah, because you really had that one all the way out. It was just a matter of questioning where to put the variable. So you were fine. You were great. You're doing awesome.
Thank you.
One of these, when I was working on them earlier, I copied the problem down wrong. And I was like, oh, all that work for nothing.
It's all right. Okay. So it's 1 minus 1 in the numerator. How would that work out in subtraction?
I have, yeah, so it's like 1/6. Is that what you mean?
I think I was just confused. I was subtracting numerals since they're both a 1.
Oh, okay. And if the result is positive, it stays at the top. So like if you have, let's just take a look. The original problem starts out at negative 6x to the 1/2 over 2x to the 1/3. So then that turns out to be 3. And then you got to get a common denominator of 6. So 2 goes into 6 3 times, and 3 goes into 6 2 times. So 3 minus 2 gives me a 1/6. So my final answer is -3 to the 1/6 power once I combine these. You end up with only one of the x's, and the result of the 3/6 minus the 2/6. If it's positive, it stays at the top. If it's negative, it stays at the bottom.
Okay. All right. And then we have 25 to 28.
Okay.
So those last 4.
Okay, so 25 to 28.
Yes, ma'am.
All right, so what we're going to do is the only reason that you're doing the operations on 25 through 28 is to figure out if the domain is going to change, because once you combine the two functions, the domain would change because it would be limited. So what we would do for the first one is you look at f of x, 2x plus 2, and then you look at g of x, and you're adding that. So technically, it's x squared plus 2x plus 2. Is there any real number that you can think of that you couldn't plug into here? And probably there wouldn't be any limitations, because limitations are going to have to do more with if you don't want 0 in the denominator. That's where you're going to end up limited. But when you have something that's straight across like this, typically you're not going to be limited. But since the beginning of time, you cannot have a 0 in the denominator. This is a no-no.
Okay. All right.
So that is what's going to limit the domain. Is no zeros in the denominator. You cannot divide by 0.
Okay.
So for number 25, the answer is all real numbers.
Okay.
Now, on 26, we have h. So you don't have to work it all the way out, but you do have to take a look at it and think, what could you not plug into this? What would make the denominator 0?
2.
2. So this is going to be all real numbers except x cannot equal 2.
Okay.
So the answer to 26 is all real numbers except x cannot equal 2. All right. H. We've got 3. Oops, sorry.
All right, 27.
3 over x minus 2 times x squared. All right, let's think about this. We've got something, we've got a rational expression here, which tells us we've got something, a variable in the denominator. What could x not equal? Because you cannot have an x in the denominator.
2.
2. So once again, it's all real numbers except 2. X cannot equal 2. Now number 28.
Okay.
So that's g of x. So that's going to be x squared
over 2x plus 2.
Over 2x plus 2. So now what we have to do is solve to see what x couldn't equal, because this can't be this cannot be 0. So we'll set that equal to 0. So x cannot equal -1.
Okay.
So it's all real numbers except for x equals -1.
Okay.
And that's it.
All right.
Does that make sense to you?
So you just plug it in, and then it's just like -1 will equal 0 in that entire equation.
Like, yeah, because let's just double check our work.
Okay.
If I plug in a -1 here, -2 plus 2, that equals 0. And I can't have a 0 in the denominator. So the domain is limited when the denominator is 0.
Okay.
So that's what you don't want to have happen. Does that make sense?
I think so. It's just kind of weird.
Yeah.
I'm trying.
Yeah, I understand. It is kind of weird. But each one is going to look a little different. So what you have to do is think about if you're ending with a fraction of some sort, like 28, even though it didn't have that h in it that did have a fraction, it still is expressed in a fraction, like, because this is the answer for 28. X squared over 2x plus 2 is the answer. Okay? So whatever would make this a 0 can't be in the domain of that combined function.
Okay. All right.
So let's just take, for instance, whether if that's the only one that has that, isn't it? Okay, I tell you what, let's do this for just a minute. Let's go back, even though we didn't really have to kind of bring the point home. Let's go back and take, even though this isn't a real problem, let's say that you were asked to do I'm trying to find something that's relatively simple, but none of these really are. I'll just make one up. F of x divided by g of x, and let's say the result is 2x plus 5, and let's just say that f of x is 2x plus 2. Okay? So we're actually using this function and this function. What you would want to do, and if you were asked to state the domain of the operation, you would take the denominator and you would set it equal to 0 to find out what would make the denominator a 0.
And you just plug it all in.
Yep. And this, in this case, it would be all real numbers except for -5/2.
Okay.
Because that would make the denominator 0.
Okay. So yeah, okay, I see that. It's because every other number would work except 5/2, because 5/2 would make it 0.
Yep, that's it. Perfect.
All right.
Nailed it.
Got
Nailed it. Awesome.
All right. Well, yes, ma'am. Thank you for your help.
Oh, no problem. Glad to help.
Yes, ma'am.
Thank you for coming to Math Lab.
Yes, ma'am. Have a good one.
You too.